Okay, we're back for part two. Here we go. This is summer, should be the next page. Summer in the U.S. In the U.S. or north of the equator at the very least. Okay, so please pause this and copy this down. Okay, you should have this down. So what we're seeing here is axis tilted towards the sun, North Pole towards the sun. It's on June 21st is the first day of summer. So it goes from June 21st, 3 months is the summer period. So June, July, and August into September. And what it looks like close up. Tilted this way. The sun is coming this way. If we're in New York, the sun is higher in the sky for us. This person down here in the southern hemisphere, this is directly overhead. They can have a low angle sun. It's winter for them. It's winter for them. So northern hemisphere is tilted towards the sun. The sun is high in the sky, but not directly overhead. The sun is never directly overhead for us in New York State. Never directly overhead. That's key, and it's warmer for us. And here's some of the sort of like basic facts that we have. So please pause this and copy this now.
Students, the late buses are out in front of the school. If you are not on them yet, please do so.
Okay, we're back. First day of summer season, June 21st, called summer solstice. The location on Earth, the furthest north it gets, that is the sun was directly overhead, 90 degrees from the horizon. At solar noon that day, 23.5 degrees north. It's called the Tropic of Cancer. Length of daylight in New York, around 15 hours. Around 15 hours of daylight, meaning 9 hours of darkness. You've experienced that in the summertime. So nice. 24 hours of darkness exists at the South Pole. The North Pole has 24 hours of daylight on that day. The sun does not go down for quite some time at that time of the year. You probably remember that these extremes from the article we read about Norway, they're close to the North Pole, so they have an extreme 4 months of darkness. They have 4 months of light in the summer season. The angle of insolation at solar noon in New York, 72 degrees up. Again, from the horizon, the highest it gets at solar noon, 72 degrees up is that angle. Pretty high, but not 90, not directly overhead. Okay, these are things you're going to need to know. On to the next one. Here's the fall spring, and what we have here is this. Please pause this and copy this down now. Okay, now what we have, and it's a little hard for this picture, and we'll do a little more three-dimensional stuff in class. Now you have the axis tilted to the side, kind of, I say neither toward nor away. So if this would be the axis pointing towards you, the camera, and if this is the axis pointed away, like this would be tilted like this direction, this way, or like that way, the axis of Earth. Can you dig it? Figured you could. All right, know these as well. March 21st, September 23rd. Again, sometimes it can be 22nd or 24th, and this could be 20th. This year it was the 20th. It could also be 22nd, but those are the main days that we use. And then here we go, some basic info about those. Please pause this, copy it now. Okay, first day of fall is here. It's called the fall equinox, also called the autumnal equinox. And people know the word autumn, so people are used to it. First day of spring is March 21st, called the spring equinox, or vernal equinox. That's a word you may not be used to. The sun is directly overhead at the equator on both of those days. It's the only day it's directly overhead at the equator is those days. And the length of day everywhere on Earth is 12 hours. 12 hours of sunlight, 12 hours of darkness everywhere. And that's sort of the idea of equinox. 12 and 12 is equal, sunlight, daylight. Sunlight, nighttime. And the angle of insolation at solar noon, the highest it gets, is 48 degrees above the horizon. That is an important number. Those numbers you need to know, commit to memory. Trust me on this one, you do. Okay. And this is a good tip. Look, just remember that kind of 24. 24, add 24, it's 48. Add another 24 to that, 72. Okay, so I encourage you to do that. You don't need to write this down. You can if you'd like. Okay, one thing I'm going to add is this right here. When you see this kind of picture showing the sun's path through the sky that they have labeled as an observer, this right here with the yellow that I just highlighted, that's highlighted already, that is the horizon for that person. That's key. Somebody seeing the perspective here is important. That's the horizon for that person, key. Zenith, directly overhead for that person right there, okay? So that's another thing that another term you need to know is directly overhead, 90 degrees from the horizon is zenith. And maybe we'll just, I'm going to stop here for this part right now.